Open weight cost revolution. Open weight cost revolution. The Financial Times reports that enterprises are quietly migrating to Chinese open weight models to cut inference costs. A shift the community has been predicting since Anthropic's Mythos/Fable era licensing restrictions. The corporate calculus is straightforward. When an employee's weekly AI token budget rivals their salary, and the CEO mandates usage metrics that look good to investors, something has to give. For many teams, that something is the provider. One commenter captured the prevailing mood. Their company spent double a developer's weekly pay on Anthropic tokens, so when told to use AI harder, they looped the shit out of it. The geopolitical undertone is loud. A separate thread asks why no American open-source lab is even close to Chinese ones on benchmarks. And the community's verdict is blunt. This is not an AI bubble. It is a US frontier models bubble. The cost pressure is compressing the stack all the way down to the device. PrismML, a Caltech spin-off backed by Khosla Ventures, claims to have compressed Qwen 3.6.2.7b from 54 GB to under 4 GB using ternary quantization. Small enough to run on an iPhone 17 Pro with all 27 billion parameters active simultaneously. Apple's own on-device model, by comparison, activates only 4 billion of its 20 billion parameters at a time. The community is skeptical. Paper or it didn't happen is the prevailing response. And the legitimate concern is whether QAT at this compression ratio preserves capability in ways that matter beyond benchmarks. Tool use, long context reasoning, the things that make a model usable rather than merely impressive. While PrismML squeezes parameters, BottleCap AI attacks the other side of the cost equation, thinking tokens. Their thinking cap fine-tune of Qwen 3.6.2.7b cuts reasoning tokens by 46% on average. Over 60% on the hardest benchmarks like GP, Q, AD, IAMD, while tracking the base model's accuracy within a percentage point across 12 out-of-domain benchmarks. The key insight is that long reasoning traces have become conflated with intelligence when they often represent inefficiency, the model narrating its solution rather than solving. An accidental side effect, shorter answers after the think block, turned out to be the feature users preferred. The model ships under Apache 2.0, so anyone running Qwen locally can swap it in and have their token spend immediately. At the extreme end of the democratization curve, a developer got GLM 5.2, a 744 billion parameter MOE, streaming from disk on a consumer machine with just 25 GB of RAM. The speed is glacial, but the community correctly identified the real point. Nobody is going to use this for production inference. The interesting part is that you can stream 744 billion parameters from an NVMe at all. As one commenter noted, we went from overnight movie downloads to overnight model inference. Nature is healing. If expert routing prediction improves enough to prefetch the right experts before they are needed, the entire economics of local inference changes. Inference Engines. The Rust Wave. Inference Engines. The Rust Wave 3 projects this week point toward Rust becoming a serious contender in inference, a space long dominated by C++ and CUDA. The most striking benchmark comes from mistral.rs v0.90, which claims up to 1.8x faster CPU decode than llama.cpp on Qwen 3.4b/Q4K across both x86 Sapphire Rapids and ARM GB10. The optimizations are granular. AVX2, AVX 512 ARM Noon. And the team swept configurations for both engines to ensure the comparison favored each at its best. The benchmarks were run on Qwen 3.4b/Q4K at varying context depths, and mistral.rs came out ahead at every measured point on both architectures. Full methodology and repro scripts are published, with an open invitation for independent reproductions on untested hardware. At the opposite end of the maturity spectrum, a developer built Ferrite, a from-scratch inference engine for QWEN3.5's hybrid Mamba-Transformer architecture entirely in Rust with no GML candle or PyTorch dependency. The project parsed raw GGUF bytes, wrote its own dequantization kernels across 8 mixed quantization formats, and implemented the full forward pass by hand. The architecture. Alternating gated DeltaNet, a Mamba family SSM with standard GQA attention every 4th layer. Exposed implementation traps invisible from papers alone. Interleaved memory layouts for gated attention. Silent weight ordering bugs that produce plausible-looking but wrong floats, and a missing pre-normalization step that caused gate values to grow geometrically with depth. The generated text is not yet coherent, but the diagnostic methodology. Comparing hidden states layer by layer against the Hugging Face reference, then using a BF16 quantized precision sweep to distinguish logic bugs from quantization noise, is a contribution in its own right. Meanwhile, llama.cpp P shipped B9978 to fix a checkpoint bug that disproportionately hit agentic workloads. Every agent turn was creating a new checkpoint, regardless of minimum step spacing, collapsing the coverage window so that context rewinds. Common in tool calling loops. Erased all checkpoints and forced full reprocessing. For multi-turn agent sessions, running tool calling loops with frequent context rewinds. This was the difference between fast context restoration and minutes of wasted recomputation. A fix that matters more as local inference becomes the default backend for agentic workflows. Model Surgery and Hallucination Mapping. Model Surgery and Hallucination Mapping, a community member who previously failed at expanding Gemma 4's depth. The 88-layer flop, documented in earlier posts, returned with a working approach. The key discovery? Initializing new layers as pass-through starves them of learning signal. As the author put it, a worker who does nothing gets no feedback. Instead, XGemma 445b initializes each new layer as a blend of its two neighbors, expanding from 60 to 77 layers. 2 rounds of healing. First training only the new layers while the original stayed frozen, then unfreezing everything. Produced a model that matched the original across 9 of 10 domains and beat it on a physics problem the parent got wrong. The question involved relativistic energy at identical de Broglie wavelength. The parent forgot the electron's 511 keV rest mass. The author watched the model heal in real time during training. Before healing, hitting a rare technical term derailed output into repeated non-Latin characters. 13% into round 2, the model stumbled once then recovered. By halfway, the problem vanished entirely. The technique challenges the conventional wisdom that major surgery on a fine-tuned model inevitably causes catastrophic forgetting. On the diagnostic side, an independent researcher stress-tested Anthropic's J-space hallucination signal across 11,400 examples and 7 datasets on Quen34b, drawing sharp lines around where internal workspace entropy works and where it breaks. For factual retrieval on PopQA, J-space caught high-confidence errors with 100% precision where output log probs managed worse than chance. On truthful QA, adversarial human myths, the signal collapsed entirely. Even in the safest quadrant high confidence, clean workspace, the model was wrong 84.9% of the time. The mechanistic takeaway. Workspace noise detects epistemic guessing, but cannot detect ontological falsehoods burned into pretraining data. Math posed a different problem. Correct GSM8K answers had higher mean noise than the factual error threshold, because step-by-step reasoning is structurally high entropy. Static thresholds do not transfer between memory retrieval and computation. Code quality in the age of AI. Code quality in the age of AI on Cloud 5 takes the ensemble approach to AI code generation and builds a full production pipeline around it. 3 models from different providers, Kimi K2.7, GLM 5.2, and DeepSeek V4 Pro. Review every coding decision through a structured counsel process with arbitration on disagreement. 4 zero-cost infrastructure layers handle 57% of tasks before any API call fires. A stdlib/native pattern matcher, an immune memory system storing 19 failure patterns, 60. 95% context compression for long sessions, and a quality gate enforcing a 10/10 threshold across 7 dimensions. The claimed result: frontier matching code quality at roughly 1/100th the cost of a single model approach. Shipping fully open source under BSL 1.1, transitioning to MIT in 2030. The verification pipeline is not new, but the parallel to a much older discipline is instructive. In 1996, Fast Company profiled the Space Shuttle's onboard software group, 260 people writing a 420,000-line program that had accumulated exactly 17 errors across its last 11 versions. Their process was obsessively process-driven. Every change logged, every error root caused, every fix verified against every prior fix. The software cost $35 million a year. What made it work was not talent or tools, but a culture where the process was the product and the error database was the most valuable artifact the team owned. The group tracked not just what broke, but why each class of error had escaped detection, then fixed the detection rather than the symptom. Today's multi-model verification pipelines grope toward the same principle from the opposite direction. Instead of perfecting a single codebase through institutional discipline, they approximate zero-defect output through architectural redundancy. Jacquard approaches the trust problem from the language level. Built explicitly for AI-written, human-reviewed code, it introduces algebraic effects for controlled side effects, capability grants for fine-grained permissions, and content-address definitions so that every function version is immutable and auditable. The design bet is that if the language itself makes unsafe patterns structurally unrepresentable, no unchecked side effects, no ambient authority, no mutable global state, then human review of AI-generated code can focus on whether the logic is correct rather than whether the implementation is safe. CMMC reform. The floor shifted. CMMC reform. The floor shifted on July 13th. The Department of Defense suspended the November 2026 transition to mandatory third-party CMMC assessments and stood up a 60-day reform task force. The stated reasoning, that the certification program was pricing small firms out of the defense industrial base, is true. But a former CISO who has built government community enclaves from both sides of the data path offers a sharper reading. The security baseline did not change. NIST SP 800.171 Rev 2 is still the standard. DFARS is still in force. What changed is the floor underneath the companies that were never going to take the baseline seriously. When you suspend the third-party check but leave self-assessment and the legal attestation in place, you raise the stakes for honest contractors, who now sign continuous compliance affirmations with more legal exposure and less external validation, and lower them for everyone else. The author's 11 proposed reforms target the apparatus rather than the controls. Continuous evidence feeds from monitored commercial tooling. Inter-rater consistency standards for assessors, independent appeals that do not route through the assessor who produced the finding, and risk-calibrated flowdown so that a machine shop turning a non-sensitive bracket stops receiving the same obligations as a firm holding weapons design data. The AI feedback loop. The AI feedback loop, a new paper from Meta and the Elasticity Institute, models the economics of recursive self-improvement and concludes that the feedback loops are not yet strong enough to generate self-sustaining acceleration. The core question, for a 1-unit increase in model capabilities, how much do the capabilities of the next generation increase? Their calibration puts the current AI R&D boost at roughly 9%, well below the approximately 15% threshold they estimate would be needed for the loop to become self-sustaining. The paper models the relationship as a directed graph of elasticities. Net acceleration depends on the product of elasticities across each feedback loop, and the gap between current and critical remains significant enough that a gradual strengthening, not a sudden ignition, is the expected trajectory. The paper distinguishes between narrow capabilities, improving at AI R&D benchmarks, and broad capabilities, improving at economically valuable tasks. A distinction that matters because a system that optimizes itself may not proportionally improve at everything else. Arvind Narayanan's ICML 2026 keynote frames the broader context. His AI as normal technology argument holds that the effort is shifting from building models to evaluating what they produce, that AI is transformative but not superintelligent, and the hard problems are now measurement, integration, and organizational absorption rather than raw capability. If the binding constraint is evaluation rather than generation, faster models do not automatically produce faster progress. A practitioner's video essay on organizational transformation sharpens this into operational advice. The core claim. The distinguishing factor between companies like Anthropic that ship weekly and everyone else is not AI tooling, but organizational wiring. 15 rules for moving a company toward a faster shipping cadence that boil down to one principle. Find the point of greatest leverage and move scarce human judgment to that point. The photography analogy lands. Film's cost imposed discipline on how many shots you took, and digital removed that discipline without removing the need for curation. AI has done the same to all of work. The cost of another draft is collapsing to zero, but the choice of what deserves to exist has become harder, not easier. Creative AI and agent tooling. Creative AI and agent tooling, Apple's new speech analyzer API, shipping with iOS 26 and macOS 26, replaces SFS speech recognizer with no published accuracy figures. An independent benchmark on M2 Pro fills the gap. Speech Analyzer achieves 2.12% word error rate on LibriSpeech Test Clean, beating every Whisper model including Whisper Small, while running roughly 3 times faster. The old SFS Speech Recognizer came last, behind even Whisper Tiny, a 40 MB model. Apple published no accuracy figures for either new API, so every developer deciding whether to migrate has been guessing. Until now. The migration case is closed. A CLI tool demonstrates Claude's vision capabilities in an unexpectedly practical niche, extracting guitar tablature from YouTube lesson videos. The pipeline downloads the video, samples frames, uses Claude Vision to locate the tab region via labeled horizontal band grids, deduplicates by bar number, and stitches the distinct lines into a PDF. No configuration needed. On the video generation side, a curated collection of Blender decedents workflows documents how 3D scene authoring in Blender can feed into AI video generation for filmmaking. The approach gives creators precise spatial control over camera, lighting, and composition in Blender, while letting decedents handle photorealistic rendering and motion synthesis, bridging the gap between deterministic 3D control and generative video output. World Foundry takes a more systematic approach, providing a unified framework for world model inference and evaluation. The standardized benchmarking infrastructure that video generation needs before it can move beyond demos into repeatable production. In the agent infrastructure layer, Open Connector positions itself as an open-source alternative to Composio, offering a unified gateway to over 1,000 service providers with MCP-ready tool exposure. Connect once, use everywhere. OakLab's research mission aims at a different problem entirely: building agent architectures that discover temporal abstractions grounded in experience, learning in real time without storing or replaying data, using orders of magnitude less compute than existing methods. Where most agent work assumes foundation models as the reasoning substrate, OakLab is working on the substrate itself. Algorithms that assign credit to parameters that generalize well, rather than to all parameters, enabling learning directly from noisy experience instead of curated datasets.